Good morning, Jeff.
Good morning, Jeff.
And are you gonna lead us in this morning?
Yep. Good morning, good afternoon, everyone, wherever you are. Happy New Year. Welcome back to our shows. We've taken some really good break, I would say, but It's time to be back, and we are happy to be back. So the topic of today's show is going to be managing EVPN with AOS. Why we wanted to do it, we've been talking about EVPN for the last 3-4 months. And we've discussed IETF part of it, encodings. The intention here is to kind of tame the complexity and show you how one can simplify the configuration and how this kind of abstracted encoding that's done in IETF finding its way into intent-based system and eventually vendors' devices. So today we are going to go through slides. As we promised before, eventually we'll start doing live sessions with running setups, showing you the before, after, how different routes are get populated and how they look like and why.
And it's we should mention while the slides are coming up that even though we're both with Apstra, and it's probably not a surprise to any of you that eventually we would be talking about Apstra operating system, AOS. But what you've seen over the, gosh, how many sessions have we done? A ton of sessions.
Countless.
On VXLAN, EVPN in the data center, and DCI and all those related things. And you saw both the utility of that and what a great technology it is, very useful technology in the data center, but also very complex. And if you start looking at, a data center of really any significant size at all, it becomes very much an operational challenge to manage an EVPN network. And so what we want to show you without doing a sales pitch is just the matter of this is where we work and what we work with every day. We want to show you one example of an intent-based networking system that simplifies all of that management, and hopefully it will. What we're going to be showing you will kind of solidify all the concepts that we've been talking about, and give you some really interesting graphical perspectives on all of this. Looks like your slides are up there, Jeff.
Yep. Just not. Yep. So anything you would like to know EVPN, we are here on LinkedIn, on Twitter. Do ask us. We would be happy to address any of your questions, and the focus is really EVPN here. So if we look at hierarchy of planes in DC network in context of EVPN VXLAN, we've got management plane, which is provided by AOS. AOS takes high-level requirements or intent and translates it into networking concept. What we are going to focus today is the overlay control plane, BGP EVPN. If you look at DC Fabric as such, we are talking about leaf-spine networks here, obviously. It has many connections, has many components. The EVPN component is the core of the network, so the leaf, spine, super spine, leaf part that goes over the fabric. For sake of this discussion, we are abstracting anything in between. So from our perspective, connectivity and services are leaf to leaf. And this is what BGP EVPN domain is. So this is what we call BGP EVPN Fabric. We don't instantiate services on any other devices. Practically, you want to have your services on leaves in very, very niche cases, maybe on spines, but for all practical reasons, you would like to terminate complexity at the edge and have your core to be fast and simple.
Yeah.
So as long as we have connectivity between VTEPs, which are BGP next hops in EVPN, we are fine. Doesn't matter how complex your fabric is, how many planes it has. From overlay perspective, it's simple point-to-point connectivity, or point-to-multipoint in case of EVPN, actually. So could be very simple three-stage network with 4 switches. As long as we provide connectivity between all leaves that participate in the service, we are fine. Underlay control plane can be provided by a variety of routing protocols. In Apstra, our reference designs are with eBGP on physical interfaces, specifically on physical interfaces to provide fast recovery, because we would like to BGP session to go down immediately after something is happening. Link is going down, could be BFD triggered, but this is how convergence is triggered. It's by underlay next hop becoming unreachable. And we would like this to happen within milliseconds. So there's a number of IETF documents that define what EVPN is. There are more and more documents. We are coming with more advanced use cases. A very good topic for another discussion. The job of AOS here is to make sure that all different RFCs, drafts, technologies that implemented, interwork, tested, and when you express your intent throughout AOS, it's implemented and instantiated as working networking as well, something that could be completely validated. A bunch of drafts. There's even more drafts as we speak. And again, I think it would be a very good discussion to go through sometime in the future.
Absolutely.
Specifically to data centers, we are talking about VXLAN. So I'll do a short recap. Why VXLAN? At some point in life, we needed L3 encoding for L2. And VXLAN became the consensus encoding for this kind of information. Very unfortunately, VXLAN didn't have next protocol field, so it's layer 2 encoding. You cannot, we use it for layer 3, but we are hacking around. In interfaceless EVPN, for example, we provide MAC address and extended communities that attach to IP prefix route. So VXLAN is dominant overlay encapsulation today. We see new encapsulation coming up, Genève most predominantly, next gen VXLAN, which is GP VXLAN. They're very similar in a way, but the most significant difference, they all not limited to layer 2. Based on next protocol field, you know what's below.
You mentioned interfaceless EVPN?
Yeah, so in interfaceless VPN, or interfaceless IRB, to put it in right context, what it means is that you don't need route type 2 for route type 5 to resolve. You use attached extended community, that's MAC router, to resolve route type 5s. So if you look at VMware implementation of EVPN or Junos implementation of pure type 5 fabrics, that's exactly what they use. Practically, VMware wouldn't even exchange route type 2, 3, or 4 with you. The only route type that's coming out of NSXT 3.0, 3.1 BGP speaker would be type 5. Since it includes the router MAC, we can resolve route type 5 without need for route type 2.
Got it.
As you know, VXLAN is a UDP-based protocol, so we are going to use source port for entropy, and VXLAN network identifier, or VNI, is the only data plane component that allows us to differentiate between different subnetworks. If you look at any implementation ASIC today, it will look at VNI. Same way we look at MPLS label when we do MPLS lookups, and based on the value in VNI, produce or yield context, which could be bridge domain for layer 2 VNIs or VRF or routing instance for layer 3 VNIs. Let's start with route types and how they interrelate and how it looks like in AOS and vendor devices. Let's start with basic route types here. Route type 2 that advertises MAC addresses. MAC address is a mandatory field, or MAC and IP address where IP address is optional. So when we receive traffic that has MAC or layer 2 frame, we will advertise MAC address as EVPN route type 2. When we receive an ARP that has IP address on it, we will also advertise IP address next to MAC address. Depending on implementation, we might also advertise IP part of it as route type 5, as a host route. Route type 3 is specifically used to figure out who are other people that participate in the same bridge domain or EVI. Because as we remember, EVPN really resembles large bridge. So when we receive unknown unicast, multicast, or broadcast traffic, it must be sent to every other switch that participates in the same EVI. So route type 3 is used for these purposes. When you configure a EVI on any device, it will automatically advertise route type 3, telling everybody else, guys, I am part of the domain. Do you have anything to flood to me? This is what you do. And it used somewhat differently in MPLS cases, which we are not going to cover today. Route type 5 is a late addition to EVPN. It's not part of basic RFC. It's still a draft because of misref, but practically has been implemented by every vendor. So this is a specific part that advertised IP prefixes. Why we didn't use route type 2 for IP prefixes? The network length or prefix length in route type 2 can only be a host route. So /32 in IPv4 case or /128 in IPv6 case. Route type 5 doesn't have those limitations. It could be any prefix. And as we mentioned, pure type 5 fabrics before, in this case, you use only route type 5s. So it becomes really L3 VPN over EVPN.
Yeah.
So let's start with route type 2. This is a very nice graphical representation we've borrowed from someone. So as we said, MAC address part is mandatory. IP part is optional. We still call data plane fields MPLS labels because EVPN came up as MPLS technology. Practically, this is where VNIs are going. MPLS label 1 is L2 VNI, to associate it with MAC address, and mandatory. MPLS label 2 is L3 VNI and is optional. And only if IP-related information is present, it should be in the route type 2. Otherwise, it's not needed. The other attributes here, we set router MAC address is needed to know who the router is. MAC mobility, actually, we never covered it. Probably would be a good idea to cover how VPN deals with MAC mobility. So something for the upcoming webcast.
Definitely that.
And tunnel encapsulation is really important because you really need everybody that participates in a service to agree on encapsulation. In case of VXLAN, it's set to 08, which is VXLAN. So when we advertise the route, we always advertise how it should be encapsulated when sent to you. Because imagine I support number of encapsulation. Could be any NVO3 encapsulation, be in Genève, VXLAN, something else. I need to know how to encapsulate traffic where I send it to router or switch that advertises route. And since now I know which type of encapsulation it is, I can correctly encapsulate traffic and send it. Now we are going to look into workflow on iOS and how we populate those fields.
And it should mention this is the first glimpse of part of the actual AOS UI.
The main job of iOS is provide you to very, very simple and intuitive workflow to configure attributes for your data center networking. In this case, we are creating virtual network that could be of type VLAN or VXLAN. Since we are talking about EVPN VXLAN, it's always going to be VXLAN. From a relationship perspective, a bridge domain has to be attached to a VRF or routing instance. In this case, it's already pre-configured routing instance blue. So the only value that is asked you to provide is really VNI ID. That could also be automated through resource allocation, but for sake of this discussion, we are assigning VNI ID 10,000. This value is what you're going to see in label 1. When router receives an advertisement with VNI ID set to 10,000, when it's going to send traffic towards the switch, it's going to encapsulate traffic in VNI 10,000. When switch that advertiser receives it, it will do lookup on VNI value, which is easy to do from Silicon perspective. It's fixed offset. We know the length. We know where it is in the update. And immediately say, I know it's a virtual network that attached to VRF Blue. So it could immediately be used. From connectivity perspective, you might use EVPN in two basic modes. One is bridge overlay, meaning you are actually not allowing any IP processing. All the traffic received is going to be treated as within bridge. So you need a layer 3 device that's connected into your fabric, very often being firewall, for example, that is going to be first hop for layer 3 processing. So in classical design, when firewalling is needed, you would provision bridge overlay domain in exactly what you see here, have pair of firewall connected to border leaves, and use VRRP or some other clustering technique to provide resiliency. So this is classical overlay network without routing. From population of other fields in iOS, we always explicitly populate them. So we don't want to guess whether something is auto-generated. As you could see, RD is loopback and VLAN, so we know the values. ESI is set if ESI is used. So we went through multi-homing. You should know by now what ESI is. Tag ID, if it's VLAN-based, it's going to be set to 0 because relationship in VLAN-based SI is VLAN to bridge domain to EVI. If it's other service interface, it would be set to that of VNI. Route targets is again very derivable. It's VNI, which is 10,000 column 1. So when you look at definition here, you know exactly how configuration is going to look like. And this is exactly the result. I'm using Junos and EOS, where EOS is representative pretty much for C-star Cumulus. They're very similar. If you look at Junos...
Arista EOS, for anybody that doesn't know EOS.
This is the VNI provisioned, 10,000. Route target is auto-derived, so it's VNI column 1. And this route target is going to be used to import traffic that comes from somebody else with this route target, or to export traffic that's sent to the switch that advertise routes in the same EVI. So we are going to tag the route type 2 with route target 10,001. This is kind of configuration that's relevant to which VLAN is going to be part of this network. So we said it's VLAN 100. This is the layer 3 interface that I'm going to cover next. And so this is really the mapping from VLAN 100 to VXLAN VNI 10,000. If we look at Arista, very similar. The RD, so RT again, it's auto-derived from VNI 10,001, and basic mapping of VLAN 100 to VNI 10,000. So while configuration is pretty different, we achieve exactly the same result. We want to map VLAN that's incoming to VNI that's outgoing, and associate RDs and RTs with route type 2 and 3. So as we said, route type 3 is going to be used to build a bridge domain across all different switches. All implementation will implicitly take route target configured for route type 2 and copy it into route type 3, because they have to match. Any bridge domain must have full set of type 3 routes in order to emulate bridge.
And before you go to that next slide, or actually this slide here is good too. One of the things to emphasize specific to Apstra AOS is that these are the specific configurations, but if you're using AOS, you don't go to this level. You actually have that interface. There you go. And you just generically specify the variables you need. And whether your infrastructure, as it was shown here, is Junos, or whether it's Arista EOS, Cisco NXOS, Cumulus, what am I leaving out? Sonic. The system itself will take care of taking your specification and generating the vendor-specific configuration stanzas right there that you need for whatever device you have in your network. And maybe you have multiple devices in your network from different vendors, and it will generate for each of those devices the appropriate and the consistent configurations. And that is a big part of simplifying the management of VXLAN EVPNs.
So practically most of complexity is completely abstracted from you.
Yeah.
What your intention is to have a layer 2 domain, and that's the only thing you need to express.
Absolutely.
Underlying logic will take all the resources needed, since it knows how to generate what is the target configuration. It will generate data model and then translate this data model into particular vendor's configuration.
Mm-hmm.
So we've talked about bridge overlay and generation of route type 2. Another most common mode is when you actually do IRB on the leaves, meaning you have layer 2 and layer 3 on the leaves. And very often, or actually in all deployments, we use concept of Anycast Gateway. Why it's important? When you have VMs that are mobile, or any entity actually that could move across different switches, you don't want it to have different MAC or IP address for its default gateway. When we use Anycast gateways, same IP and MAC addresses are configured on all switches that participate in the same service. So if you move from data center 1 to data center 2 as part of VM migration, if you are part of same service, your Anycast Gateway IP and MAC address is going to be exactly the same. So VM can start immediately sending traffic because nothing changed. EVPN control plane will also take care of updating who is connected to this particular VM. This is where MAC mobility is coming in, so we're not going to cover it now. But for sake of VM mobility, Anycast Gateway is very important. So if you look at configuration here, now you see that we have enabled IPv4 connectivity. By the way, IPv6 connectivity is also supported. AOS always treat IPv6 as first-class citizen. So it's a screenshot below. You have exactly same configuration feature set for IPv6. So what we do now, we configure IPv4 subnet that is going to be on the IRB or SVI interface and Anycast gateway. MAC address is auto-generated by the system itself. The end result of configuration is on Junos. So you could see it's 10.0.0.0/24 with a virtual gateway IP or Anycast gateway of 1. You would see same configuration on every switch that participates in same EVI. On Arista, you would see very similar configuration. The association with VRF is explicit. On Junos, the interface IRB 100 would be placed in routing instance. So if we go back, you would see that configuration is done a bit differently. So association between VLAN and IRB is done here, and then you would see this configuration on the routing instance, which is the VRF in Junos terms. So what would this configuration do to route type 2? What you are going to see is advertisement of this /24 network and this /32 network as part of route type 5. So you just moved to completely different set of configurations. On switch, it would have been really different, probably hundreds of lines of configuration for large domain. In terms of what you configure through AOS, it's a single click, and you need to provide some soft data in terms of subnet and what IP address to use. The rest is configured. So now we are going to take a look at how configuration of layer 2 and layer 3 routing work together. We went through this part. So VNI ID 10,000 will go into MPLS label 1. When we configure VRF or routing security zone in AOS terminology, we are going to have another VNI that is explicitly associated with layer 3 routes. So if you are using symmetric IRB, you are going to populate this information in second part of route type 2 as well as route type 5. In some other implementations, this information will only go into route type 5. So you need both route type 2 and route type 5 to provide routing. So what we just created is an IRB on leaf scenario where you've got switching, routing, and the only thing you really need to provide is your VNI IDs for layer 2 and layer 3 VNIs. Subnet to be used, that could also be used as part of soft resource allocation. So if you have pre-configured pools to use, you don't even need to do this. And policies. By default, you can import and export everything. You can go in more details and say, I only want to export my IRB, or maybe my IRB and loopbacks. So again, you don't need to provide IP addresses. AOS abstracts away differences, giving you the business logic. Do I want only IRB? So example, if you do pure type 5 scenario, probably you would want only IRBs, which is /24 route, which would be this route. Imagine you do DHCP relay. You might also want to redistribute loopback that is part of this particular routing instance. Again, you will have a button here saying redistribute loopbacks. So you don't need to say I want loopback 1, 2, 4. You just express your intent, and AOS takes care of complete configuration. If we look at all the configuration here, so again, we've got Junos and Arista EOS. This is the VNI for layer 2 and route target associated with it. So again, route target and VNI. VLAN mapping to VNI. So VLAN 100 is mapped to VNI 10,000. VLAN 100 mapped to VNI 10,000. Now we also get the layer 3 information. So we've got VRF configuration, which has route targets of 20,000 and VNI of 20,000. So as you remember, route targets are auto-derived from VNI. In this case, it's VNI column 1. So this is exactly what you see here. All other configurations that needed for EVPN to work is generated by iOS. So you don't need to know. We pre-validate, we guarantee that what has been configured works. Layer 3 information on EOS, you configure AVRF, you configure RD associated with that VRF, you configure explicitly on EOS route target import and export policies. On Junos, it's auto-generated from the statement. When you configure VRF target, it will create implicit policies to import and export this route target. So what you see now, it's fully working EVPN configuration that is going to be deployed on 1,000 switches. You will get fully working EVPN Fabric. From intent expression perspective, you just needed to provide optional VNIs, optional IP blocks to use. Again, AOS provides you with means to provision resource pools where this data is going to be extracted from, and also made sure that different values don't overlap. And if you delete this particular routing instance or VN, it could be taken back into pool and reused someplace else. How are we doing on time?
I think we're about 3 minutes over our half-hour mark.
So I think we can stop here today without going into more details on route type 5s and keep it for the next one and take questions, if any.
We do not have any questions. So you've obviously explained this so well that nobody has any questions. Yeah, so, I think for our future shows, we will continue with this. And what we're doing is building up to a point where we can show all of this in action. And Jeff, I think you would agree that where we want to get on this. This is all great, showing all of the details that we've discussed in previous shows and how it all links into and is specified by AOS. And then it'll allow us, building this foundation, to expand out and actually give you a demonstration of running all this live in AOS.
Sounds great, and that's the plan. So potentially next podcast we could use to show how ESIs are generated, for example, for multi-homing.
Absolutely.
And cover route type 5s and how they're generated, and potentially then move into live scenarios. And guys, we would love to hear from you what you would like to see in terms of workflows, configuration. We'll try to cover all of it using AOS. And thank you for your attention.
Thanks, everybody.